This episode of Pool Magazine Podcast is proudly brought to you by United Aqua Group. For over 60 years, UAG has been changing the way pool and spa professionals buy the products and services they need. As the nation's largest and most reputable buying group, we have the resources to offer innovative solutions at competitive prices. Our organization comprises residential and commercial aqua experts dedicated to serving pool and spa professionals of all generations and experience levels. Whether you're a pool builder, retailer, equipment, or service company, UAG has the solutions you need to grow your business and increase profits. Want more information about becoming a member? Visit us on the web at unitedaquagroup.com.
Thanks for joining us on another episode of Pool Magazine Podcast. Today we're going to be discussing equipotential bonding and a study that was recently conducted by John Antonelli on behalf of the pool industry. With us today as well, we have Dallas Thiessen with the FSPA. Before we dive too deep, I wanted to ask, what role did the Pool Industry Council play in getting this project off the ground? What does their involvement say about where the industry's headed in terms of safety and accountability?
Yeah, so the Pool Industry Council, for your listeners who might not be familiar, it's a 501c4 nonprofit affiliated with the Florida Swimming Pool Association. Its main focus is education of consumers in the industry about the industry, and one of their kind of goals is to educate everybody, to put some data out. So the Pool Industry Council, they decided to commission this study so we can get some more information on equipotential bonding methods, and so the industry can be better educated about equipotential bonding, how these methods work and compare.
Sure. John, maybe can you briefly elaborate about equipotential bonding in layman's terms and why it's so critical for pool safety?
Sure. So equipotential bonding is a safety system that connects all the metal parts around a swimming pool together via bonding wires. That ensures that everything stays at the same voltage. If there's any stray voltage, then the electricity could electrify certain parts of the pool environment, but not all. And if those parts are at different voltages, electricity could flow through a person who happens to touch between two surfaces, say touching the railing on the pool deck and the water at the same time. That's what causes a shock. It's when you have a difference in voltages between those components. If everything's at the same voltage, which is where the word equipotential comes from, there's really no issue. It could be 0 volts, it could be 100 volts. If everything's at the same voltage, no shock.
What was the main goal of this study that you conducted that was commissioned by the Pool Industry Council?
So the main goal is to determine the effectiveness of the various perimeter bonding methods that are available to mitigate equipotential voltage differences between the pool water and the deck. This all came about because of a tentative interim amendment that the NFPA added to the 2023 National Electric Code in 2023 after the code was originally written, that removed the option that pool builders had to use a single number 8 copper wire as the means of bonding the perimeter surface, so the actual earth and decking around the pool itself. And that original printing doesn't have that exclusion. You could use either a number 8 copper bonding wire or a copper grid, or even if the pool shell itself was bonded into the steel rebar or wire mesh in the pool deck, that could be used as well. So the Pool Industry Council commissioned a study to test existing pools using both the single wire and the copper grid method to determine how each performed in kind of a real world scenario.
You selected 9 pools that you used in the study. Were there any surprising or problematic during testing?
The only ones that were a little bit surprising were the fiberglass pools. Fiberglass pools by nature are non-conductive shells, so they don't have any rebar inside them. And so the way you get the water actually electrically bonded to the rest of the equipment is generally through a bond fitting. The ones we tested had a stainless steel plate in the skimmer that connected the water electrically to the rest of the equipment. And when we used the exact same test method as we did with the concrete pools that had rebar in them, we couldn't measure any equipotential voltage unless we actually applied that voltage directly to the pool water itself. With the other ones, we were applying to the bonding grid itself. That was the only kind of surprising thing we found in the field.
When you looked at a few different ways to bond a pool, you indicated before a copper wire, bonding grid. Which scenario performed the best, and why do you think that is?
I guess all 3 of them were effective in mitigating equipotential voltage from occurring when we induced a simulated fault. So all of them kept the equipotential voltage at 120 volt, under 1 volt, with the exception of one of the fiberglass pools that did stray over 1 volt slightly. But if you really lined all three up next to each other, the concrete pools with the equipotential bonding grid were the most effective at reducing. So basically, the measured voltage there, equipotential voltage difference between the water and the deck for those was the lowest, followed by the fiberglass pools, followed then by the concrete pools with a single wire perimeter bond.
Yeah, I was reading through the report. I mean, what does the data say about the effectiveness of inline water bonding system in fiberglass pools compared to bonded concrete pools? I was hoping you can maybe elaborate about that a little bit more.
Right. So like I said, in fiberglass pools, there's really no way for the water to get bonded in the pool to get bonded to everything else unless you have a metallic component, conductive component in contact with water. So whether you're using some kind of fitting that's in the pool itself, or you have this plate in the skimmer, that's going to be different than a concrete pool. You're basically in a concrete pool that has rebar in it. The rebar itself is conductive, and the concrete is porous enough that you do get that electrical connection between the rebar and the water through the concrete. So we found that was second place, I guess, if you wanted to rank the effectiveness of the three main types that we tested here in this study. We didn't test any concrete pools that have water bond fittings. Not too many pool builders use a water bond in a concrete pool with rebar, but some do, and that might be something maybe that would be worth testing in the future.
We have a lot of pool pros that listen to our podcast. From a contractor's perspective, what's the minimum they need to get right to ensure safe equipotential bonding?
So based on what we found, at minimum, the contractor should follow what NEC 680.26 states. They would need to ensure that all the metallic parts, electrical equipment, surrounding perimeter surfaces, and the pool water itself and everything in that pool environment are electrically bonded together, which is key to reducing the risk of shock in and around the pool. And contractors should be able to choose a perimeter bonding system that meets their design needs and accounts for any elevated risk of stray voltage in the area, whether that's a copper grid, copper bond, or if you're using, like I said, some kind of steel mesh or rebar that's connected between the pool shell itself and the deck around it.
You conducted this survey. I mean, do you feel like the NEC doesn't specify a hard voltage threshold, should it? I mean, or is the current industry approach adequate?
I think there's far too many variables to specify a hard limit. You really can't find one in any of the research. A lot of the previous papers written kind of dance around a limit, but they stop short of providing one. And, that's because perceptible voltage is going to be different for each person in each situation. So, small children might start feeling voltage at a lower level than, say, a full-grown adult would. I think what the NEC probably should do is introduce more requirements to further limit the risk of creating any stray voltage in the pool environment, like requiring low voltage lighting in pools and things of that nature. So maybe fix it from the other end and kind of remove any of the risks that could introduce any of that stray voltage.
100%. I mean, do you feel the current code inspections are sufficient for detecting bonding issues before a pool is approved for use?
So what we found is inspections vary pretty greatly between jurisdictions. But I think besides just a basic visual inspection of the bonding before it gets covered up by the deck should be done. And they should also be checking continuity between various points in the bonding system to make sure that everything is adequately bonded. If they have any splices, those splices are tightened down and everything is kind of acting as one solid unit. And, perhaps a limited version of the testing that we conducted might be good just to kind of verify that if there were an issue, that the bonding system they installed could react to mitigate that problem.
Well, let's talk about that for a minute. I mean, what mistakes do you most often see contractors making when it comes to bonding systems?
We don't see too many contractors making mistakes on new builds these days. I think when shock issues do arise, it's because of improper wiring of some equipment or possibly damage to the bonding system after the fact. So if somebody comes in and they install some new equipment, or they change their lights out, or they have electrical work done, or who knows, then things that happen after the pool is built years down the road, that's where I think some of these issues maybe pop up.
If you were to expand this study in the future, what variables would you include the next time around?
Sure. So if we were to expand on this, I think it might be good to increase or expand the test voltages we use. We went up to 120 volts. That's typically what you see as a maximum voltage in lighting faults in the pool, but maybe we go up to 240 volts to handle any issues that may arise coming from, larger electrical equipment like the pump or heater. In addition to that, maybe testing pools that are bonded to the perimeter using steel rebar or wire mesh, as I mentioned. We didn't test anything like that. Or concrete pools that feature a water bond fitting. And then maybe testing larger commercial pools, which have a little bit of a different construction method, might also be useful data to have.
John, are there any recommendations you would give to manufacturers or builders based on your findings in this study?
So, based on the scope of our testing, the variables we've looked at, I would say the most important thing is to ensure that the bonding system, no matter which method is used, and the electrical equipment are all installed properly with equipment listed for that specific use case. Definitely don't want to have components being used that might not be listed for this specific type of use, and really just to make sure that everything is installed exactly as it needs to be.
What's the one key takeaway you hope pool pros walk away after reading this report?
So first, I think electrical safety should always be a top priority. Obviously, especially when you're dealing with pools and spas and any sort of aquatic environment. What our testing found was that both the single copper wire and the copper grid methods of perimeter bonding were effective in keeping equipotential voltage below 1 volt during 120 volt. So what we think is that either method works, and it should be up to the contractor to do. And that as long as either one of those are installed per code, we believe both are equally effective.
John, Dallas, thanks so much for spending the time with us today to discuss this new Equipotential bonding report. Really enjoyed having you guys on the show again.
Yeah, and before we close out too, I would also like, on behalf of Pool Industry Council, also thank our partners at the Pool and Hot Tub Alliance for their support in funding the study, as well as their technical advice in getting the study set up and working with SunSmart Engineering to make sure that our testing parameters were going to be efficient, to make sure that we got good data, and ultimately we're just on behalf of the Pool Industry Council, we're very happy with the results of the study, and we're very proud to produce one of the most thorough, I can say conclusively, the most thorough study of this topic to date. So on behalf of Pool Industry Council, we'd like to thank PHTA, thanks SunSmart, and then also thank Pool Magazine for being able to highlight this important research.
Well, that's all the time that we have left for today. Make sure to like, share, follow, and subscribe, and we'll catch you next time on another episode of Pool Magazine Podcast.
This episode of Pool Magazine Podcast is proudly brought to you by United Aqua Group. For over 60 years, UAG has been changing the way pool and spa professionals buy the products and services they need. As the nation's largest and most reputable buying group, we have the resources to offer innovative solutions at competitive prices. Our organization comprises residential and commercial aqua experts dedicated to serving pool and spa professionals of all generations and experience levels. Whether you're a pool builder, retailer, equipment, or service company, UAG has the solutions you need to grow your business and increase profits. Want more information about becoming a member? Visit us on the web at unitedaquagroup.com.